Hello friends, welcome to my YouTube channel and welcome to Pandas tutorial. So guys, till now we have discussed about series, data frame, addition of series, multiplication of series. We have seen this particular data set, data frame. We have talked about LOC, location function, for data frame. So moving forward, I'm going to discuss more about LOC, and there is one more term called as iloc. So we'll be discussing this in our today's video. So what I have done is I've imported my pandas as pd. Then I've prepared one data frame, so you'll be able to find my data is 3456. I've made this inside a list, and then the rows are 4567 because I don't want to give any by default row like 0 1 2 3 4. And the columns, there is only one column, that is 9, that is the column header. And then I passed all this inside my data frame. So I've used this data frame pd.data frame, and then I have stored this into a variable called as df. So df is nothing but my data frame, which consists of data 3456, rows 4567, and one column, that is 9. So this is my data frame you will be able to find. Now since we know how to access column level of data, how to access your column, we know that for sure you can give df dot 9, or you can give df in bracket of square bracket of 9. In this way we can access our columns. And then we have seen about loc, right? So suppose in this example, if I write df dot loc, loc is used basically for row level of if you want to fetch row level data, then we need to use loc. Otherwise without that we can use dot operator or square bracket to fetch our column level of data. So I've used d dot loc, and then I'm writing 4. This is my index, so fourth index, fetch my row. This is what this particular code means. So it will fetch the data, that is 3, and the column header, that is 9. So in this way we can do it. So we know by default the indexes will be 0 1 2 3 4. Now what I've done, I have overridden my default indexes to 4 5 6 7. So I have executed by writing 4. If I write by 7, so we know for sure it will give me 6 data, because for 7th index the value is 6 and the column header is still 9. Now when I give the default index, that is 0 1 2 3 4, so by default the index 0 will be nothing but the first one, that is the data is 3. So if I execute, it will give me one error saying that it cannot find what we are talking about. It doesn't know what is data inside my 0. It doesn't know what is 0th index because there is no 0 index. So it won't find this location. And the same if we give for iloc. So there is this one more function iloc. I is nothing but integer log. So it is basically the default indexes. It will read only my default indexes. So by default we know at my 0th index the data is 3. So if I execute this using my 0th indexes, it will fetch my data, right? And if I give the labeled index, so there is this two terms, one is the labeled index and one is default index. Default index we know it is starts from 0 0 1 2 3 4, and the labeled index is that we give, or that is what visible in our screen. So for now in this data frame df, the visibility of index is nothing but 4 5 6 7, which we have overridden. So currently 4 5 6 7 is my labeled indexes, and the by default indexes we know it is 0 1 2 3 4. So if we use function df dot loc, loc is nothing but it will only give my labeled index output, and iloc will give only my by default indexes values. So if I am using iloc and I am using this labeled index, that is 4, it won't find 4 because this use my by default indexes like 0. It will give for 0 1 2 3 4, but the labeled one 4 5 6 7 it won't understand. So for that we have to use loc, right? So I guess I'm able to clear about this loc and iloc. So loc is location, iloc is integer location. When the term is integer, integer is nothing but my default 0 1 2 3 4, and the labeled is nothing but we have overridden our by default and we have given our own indexes. So we have to get our row level of data using this loc function. So moving on, we also know how to fetch a list by giving your multiple data set indexes and then making this inside a list. So this is also possible. So to make this more clear, I have prepared one more data frame. So where I have this dictionary. I have prepared one dictionary basically. So it contains 4 keys: first, second, third, and fourth, and the data are in the list with 5 data set each inside my list. And then I prepared this data frame, pd.dataframe, and dd is nothing but my data frame value, variable. So over here the data is d is nothing but my dictionary which I prepared at the top, and the indexes I have overridden. Instead of 0 1 2 3 4 5, it is now showing as a b c d e. So this is now my row index, and the columns are my keys: first, second, third, and fourth. So guys, this is my data frame. Please have a good look on this data frame. A B C D E is my row, first, second, third, fourth is my column, and these are my data set. Now let's go to column level of data findings. We know how to fetch any of the columns data, right? For suppose I need first column data, we know how to give this. We can give this dd dot first, and we can give this in other way, like in square bracket dd. In square bracket we can write the column header name. If I want first and fourth, we know we have to give one more list, and we have to pass this, sorry, not one more list, we have to give basically a list. The square bracket is the format. If we want a list of column header, then we need to give a list, like in this case. So first and fourth. So we have discussed this already. So if I execute this, we'll be able to find these two columns data, right? So we know how to fetch column level data. Now coming to row level, we know how to fetch row level data as well. Now there are two ways to fetch row level data: by using the labeled is nothing but my abcde, this kind of data, or else by using iloc. If we use iloc, then we have to give the by default index as 0 1 2 3 4 5. So currently I'm using loc, so it will be my labeled indexes, row level indexes. So loc iloc is nothing but for fetching my row level data. So dd.loc, and then I'm giving this index d. So we know for sure what is in my index d, 7636. So when I execute this dd.loc and index d, it will give me 7636 and my column names. And if I want dd.iloc, then what we need to give? 0 1 2 3. For d it will be third index, so I need to give dd.iloc, and then inside my bracket it will be 3. If I give iloc, it will give my same data set. Instead of d, I am using by default index, that is 3, and instead of loc I am using iloc. So in row level, till now we have seen how to fetch only one rows. If we need to fetch multiple rows, that is also possible, like the same thing that we have did in column. Again, pass this inside my list, whatever data set you need. For suppose I need a and I need e, these two rows data I need. So if I execute this by using dd.loc, we'll be able to find only these two rows and all the columns, right? So guys, I hope till now I am very clear how to fetch column and row level data set. We know how to fetch one column data set, we know how to fetch multiple columns data set, and we know about rows as well, how to fetch one rows data set, and how to fetch multiple rows data set. Now suppose I need intersection of rows and columns. I need okay, let me just give you one example. So this is my dd, this is my data frame that we have, and suppose I need these data from my data frame. Now how to do that? So what we can do, suppose one second guys, where is my data frame gone? Yeah, so we can give this kind of operation by using this comma in my dd.loc or iloc. Now always remember the parameter that we pass inside my loc. The first one will always be my rows, and the second one will always be my columns. So Let me delete just this one. Let me just write it again. So we know dd.loc will give me rows. I'll give my bracket. So suppose mm, I need this last 7696 data, these data 7696. So we know the intersection is nothing but d and e rows and first and second column. So we'll get this 7696. So as I said, dd.loc, and in parameter the first one will always be my rows. So row is nothing but my d and e. So I'll give my rows and then comma, then I pass my list, and then what I need, column is nothing but my first comma second. In this way we'll be able to find our intersection of rows and column, and we'll be able to find some part of my data frame. This is how we can get a part by part of my data frame by using this loc function. The first parameter, this is d and e, or nothing but my rows and comma and my column names that I need. Similarly we can do it for iloc. Now if I am giving iloc, then I need to give for rows and index the default values. So the default value for d will be 0 1 2 3 and the e will be 4. We know how to make default. Similarly we need to give for columns. Column will be 0 and 1, first and second. So if I execute this, it, okay, one second, it is giving me some error. I will say, okay, yes, this is one more thing that I need to talk about. So I pass this inside a string, my mistake. So 3 is nothing but my integer. So I means integer, right? I'm not sure why I did this mistake. Yep. So if I execute this by passing my list, it will give me the same data set. You will be able to find 7696. So this is how we can make use of loc and iloc, and we can fetch our data set, some part of data set, by using intersection of rows and columns. Now moving on, I'm using this dd.loc function, which is nothing but my labeled indexes. So if I give, suppose this is my row A and B, and I need all columns. So by default it will give me all columns, and we can use this colon operation as well. It will give me all columns. If I remove this and execute it, so we know it will give me the same result. So this is one more thing, by using colon operation we'll be able to find out. And we also seen about this in our previous tutorial, like how to add a new column into our data frame. Just use the data frame and give your new column name, and whatever operation you can give a list. So for this example, what I've done is I've added two existing rows, first and second, and this will make my new column by addition of first and second column data. So you'll be able to find the new column is created, and it is nothing but addition of my first and second column. 1 plus 2 3, 4 plus 4 8, 5 plus 5 10. So this is how we can do. Now we also know how to rename our existing, how to change our existing data in a existing column. Just give the data column name and give your data, that the new data that you need to replace it with. So there is one more operation called as dd.drop. Data frame dot drop. Drop is one more function which is present. So as the name suggests, it will remove your data. Drop. So suppose this is my data frame dd. I need to remove this new column that I have created. So what I can, just forget this access what I've written for now. So dd.drop, and then in bracket I have given new column. So ideally it should delete my new column, right? If I execute this, it will give me some kind of error. It says new column not found in access. So what does this mean? It cannot find an access. So access in pandas, so if this is my graph, and by default the access 0 is nothing but my row, and axis, if it is 1, then it is my column. This is how pandas understand access. 0 means row and 1 means column. So keeping that in mind, if I click shift and tab after this drop, we'll get the definition of drop. What it says, by default the axis is equal to 0, means 0 means it will take access as row, means it will only understand our row indexes, not column. And what we are trying to do over here is deleting our column by giving the column index or column header. So for that we need to make some changes as access equals to 1, means it will now understand what my new column is. If I execute this, okay, why is this giving error? Let me check. Still it says new call not found. Okay, let me execute the top. Okay, I haven't executed this, then it won't give me this error. Yep, so I have executed this. Now you'll be able to find this new column is deleted, right? Because I have dropped my new column data set by using this dd.drop and access equal to 1 for my column. Now if I execute dd, it should be deleted, right? If I execute my data frame, you'll be able to find it is still there. The new column is still there. So this is not a permanent dropping of my data set. It is just a temporary. To make it permanent, what we need to give is, you'll be able to find there is one more keyword in my drop, this in place. So this key, if we it is by default in false condition, we need to make this true. If the in place is true, then it will make it as permanent change. So currently it is temporary because in place is false. So if I write in place equals to true, it should delete it permanently. If I again execute this dd data frame, you will be able to find it has deleted permanently my new column. And suppose if I need to delete this e row, then I just need to give I don't need to give any access because by default it will be 0. I just need to give dd drop in bracket, I need to give e comma in place equal to true. This will drop my e row, right? So now, yeah, I've again used this dd. So dd.loc we know for row level. Inside bracket we know first is row comma column. This is how we used to give. Now we can use this colon also, but we don't need to give this inside a square bracket again for rows. If I execute this as we have seen in list in our Python playlist, colon colon minus 1 is nothing but reversing my entire data set. So for rows and column, I have reversed entire data set. So it will reverse my data set. So A, B, C, D, E become E, D, C, B, A, and similarly for the columns. If we don't need to do it for column, just execute for rows. So it will only do for rows. See, first, second, third, fourth, and then it has reversed my rows indexes. So this is one more thing, guys. Now moving on. Yeah, so okay, let me just execute my dd. So this is my data frame. If I write dd is greater than 2, it will do a check to my data frame. Wherever the data frame's data is greater than 2, it will return true at that place. See, wherever it is false means my data is less than 2, and wherever it is true, it is my greater than 2 data. To get my data set, so this is just giving me boolean values. To get my data set, I need to pass this inside my data set itself, data frame itself. So dd of dd greater than 2, it will fetch me data where my data frame is greater than 2, and it will give me data frame itself. So if I execute this, you will be able to find it is giving me only data where my data frame is greater than 2, and otherwise it is giving me nan values wherever it is less than 2. So this is one more very good thing about pandas. Now again I think I have done the same operation. So for this example, I have done this for my entire data set where my entire data frame is greater than 2, it will give me values. If I need to perform this in some um, column or row level condition, then we can do that also. So dd of dd second, so what it is saying, data frame where my I'm doing this operation only for my second column. Wherever my second column is greater than 3, just show me the entire data frame. So if I execute this, you'll be able to find it is giving me data only where the second column is greater than 3. So if I go to my original dd, okay, let me execute it over here. this was my DD. So you'll be able to find there were 5 rows, and if I executing this particular code where my DD second is greater than 3, it is only giving me 4 rows. Why? Because the eighth row, the first indexes, is eliminated because the second is not greater than 3. So it is eliminating that and only giving me the data where my DD second is greater than 3. So we can use this in dd.lock also for row level in conditions. We can perform this also. So okay, let me again print my dd. So there is one more function apart from lock and iloc, that is called as ix. You'll be so basically this will be deprecated mostly in future. It won't be used. So still I am going to explain you what exactly is this. So let me just print my DD. So this is my data set. So now I think we know what is LOC and what is uh, ILOC. IX is nothing but combination of LOC and ILOC. It can work in it can work in by default indexes also or labeled indexes also. So if I write dd dot ix and if I give me a row, it will give me that data. Okay, one second. Our data frame object has no attribute ix. Okay, one second guys. Okay, let me check if it is there. idx max id iloc. Okay, it's not there, so let's just forget about that because it's not there. So we have only two, lock and iloc. Okay, so basically we had one ix in Python. So whenever we used to perform any operation using ix, it gives warning that it will be deprecated in future. So I guess it's not there till now. So it was just a combination of iloc and lock, where we can use 0, I mean integer value as well by default values, or we can use labeled. It will give us output for sure. So now okay, I have performed this one more okay, let me just use b. So basically this is my data frame for now. So I've done one more thing. This is my data frame. Okay, we know how to give condition, how to give multiple conditions. So this is what this example is showing. What I have done, I have took one variable where it is giving me dd of first. This is my column first. Okay, it is giving only give data where it is greater than 4 in my first column. So greater than 4 is nothing but my third, fourth and fifth row, 5, 6, 7. And there is this one more condition b. It says only give me where it is less than 9. So it will only give us c and d rows because the first is greater than 4, which will eliminate a and b row, and the second one is less than 9, which will eliminate e. So we only left with c and d rows. Now we are using this AND operator. So a and b, dd give me data frame where it is a and b. Okay, it will give me entire data frame where these both conditions should satisfy, where my first row should be greater than 4 and my first column should be greater than 4 and the data inside my first column should be less than 9. So it will give me entire data frame, and my first, if I see my first column, it is 5 and 7, which satisfy both of my condition greater than 4 and less than 9. And in my entire data set, so if I'm using this dd, it will give me entire data set and my condition. If I need only certain columns of this, just give your column name after this. It will only give me the column name 7 and 6. See, 7 and 6. So I guess the video had gone very long. This is it for today's video guys. We have seen many things for today. We have seen about two different functions, lock and iloc. We know the difference between these two, and we have seen how to fetch any intersection of rows and columns data. We have seen about this colon thing. We can use this particular operation in data frame as well, like we used to do in our list. We know how to give any conditions. We know how to give multiple conditions. We know how to fetch our entire data set, data frame. We know how to fetch a particular column or row using this. So thank you so much guys for watching my video. Please like, share and subscribe. Stay healthy, stay fit. Bye.